Astronomy is a science, and so I want to spend a little time talking about the process of science in general. Most of you taking this course are taking this as your science exploration credit, and so we should give some attention to what makes a science and how that process actually works. Now, you've probably learned about the scientific method. I imagine you've seen a diagram that looks something like the one to the right, where it starts out with an observation, you ask a question, you form a hypothesis, you conduct an experiment, you do an analysis of the experimental results, you draw some conclusions, which lead to new observations, and this process continues around and around. This is a really helpful tool for thinking about what goes into science. However, there's some things that are, I think, shortcomings of this description. And so there's a couple of things that I want you to keep in mind for understanding the process of science in the real world. The first is that real science is collaborative. Different people and groups contribute at all stages of the scientific method. Rarely does one person actually go through all the stages without any help. It's a very collaborative process. And also, real science is non-linear, meaning that things don't always proceed, or rarely even proceed, in this order. Observations, hypotheses, experiments, they are often undergoing simultaneously by different individuals and groups. So the scientific method as described here often gives a really narrow view of what science is, that like a single person does these things in order and that is science. But in reality, it's a lot more messy than this. And there's art to it. There's art to doing good science, and it takes a lot of cooperation between people to get science done. But the order of things and who does what is not actually that important in the scheme of things. What's important is that the process of science involves testing ideas with evidence. That's what makes something real science, that you're testing your ideas with evidence. Things get backed up. If you're interested in this distinction and what goes into real science, the University of California at Berkeley has a nice website, and you can go into that to learn more about the aspects of the process of science in the real world. But let's think about astronomy specifically. How can we apply that process in astronomy? We need evidence to test our ideas. So where does the evidence come from? It comes from observing the sky. For early astronomers, that was all naked eye observations, just looking up and recording what you saw with your own two eyes. In the modern world, we have telescopes, and that will be our primary tool. The telescope that most people are familiar with is the Hubble Space Telescope, and that's responsible for a lot of the pretty pictures that you've probably seen. That's the telescope in the top right. It's in orbit around the Earth, and there's a reason for that. We'll talk about the reason for that later on. But that's only one type of telescope. There are also telescopes for every band of the light spectrum. And if you don't know what that means, the light spectrum, that's something we'll get into more later on as well. But one example of a different telescope is the Very Large Array. Not the most creative name, but it is a very large array of satellite dishes. And this allows us to observe a different kind of light, in particular radio waves. And that's something that the Hubble Space Telescope can't do, but this can do very, very well. So in astronomy, we do science by testing our ideas with the evidence we collect from our own naked eye observations and from telescopes, and there are various types of telescopes that astronomers can use.